All right, so this next session, we're going to have two talks. And the first one is going to be by Wang, who's going to talk about a problem with email spoofing with SMTP smuggling. And I'll just let you take it away.
All right, thank you. Assume you can hear me well. So hi, everyone. My name is Gong. I'm an associate professor from University of Illinois. Today I'm going to talk about email spoofing with SMTP smuggling. This is a joint work with my colleagues at Southeast University, Tsinghua University, and our students at the University of Illinois. So email is an old system, but it's fortunately and unfortunately still a very critical part of the online security. So it is used by billions of users. There are millions of emails being sent every second. It's very critical for business communications. And for general internet users, it kind of serves as an ID card to do account verification, password recovery. So if you lose your email, you will panicking, right? So that's probably why it is a very attractive target for phishing and spoofing attacks, as you can imagine. Now, spoofing is a really important technique or tactic for social engineering. It's about impersonating a trusted sender to gain the victim's trust. So let's take Microsoft CEO as an example, right? For the sake of example, let's just say their email address is ceo@microsoft.com. So we can do some thinking exercise to say, where the risk is. So the first scenario is, let's see the attacker is internal. Let's see an intern. Some of you are intern. Or a contractor that actually have access to a legitimate Microsoft.com account. So what prevents any Microsoft employee from spoofing the CEO's address? So the answer hopefully is pretty obvious. You don't have CEO's password, and you also don't have their two-factor authentication. So that's covered. Externally, right? So what prevent attacker from setting up a attacker.com and then spoofing the sender address of Microsoft.com? Well, if you know SMTP, right? This is like 40 years old, 50 years old protocol. It itself just transmits the message. It's a networking protocol, no security features. But fortunately, we do have security extension or add-ons like SPF, DKIM, DMARC, those protocols that start to be widely deployed. So the most relevant one is SPF to this talk. So the idea here is very high level to authenticate a sender address or sender server based on its IP address. So the way how it works is that Microsoft will publish SPF record at the DNS to claim which IP addresses can send emails on behalf of Microsoft.com. Right? If attacker set up their own server, they just don't have the Microsoft IP addresses on the list. So the receiver can just go up, look up the DNS to say, okay, this IP doesn't match, so this is probably not from Microsoft, right? So we got that covered too. But unfortunately, there are new attacks that keep breaking those assumptions. In fact, in 2023, there's an attack called SMTP smuggling that actually break both of the scenarios. Well, so let's see how it works, right? Let's start with the first scenario where this attacker has a legitimate Microsoft account, let's say a contractor, so they can craft an email like this. So if you look closely, they log into their contractor address, send it from that address. The first part of the message looks pretty normal, but the second half looks a little bit strange. It looks like they smuggle a second email inside of the first email, right? That's why it's called smuggling. So this email is going to send through the Microsoft server, but the weird thing is that on the receiver server side, let's see, B.com is vulnerable to this attack. This email actually got split into two emails. So the first email is still the contractor sending some benign content, but the second message is CEO@Microsoft.com sending you a message that has any arbitrary phishing content. So that's the risk of the attack, right? So you might wonder what happened, right? Why the second email was actually created in the first place. So the trick here is just a single line of line breakers, right? So if you know SMTP operates on plaintext command. It uses /r/n./r/n as the official end of data indicator. So if you implement your email server correctly, when you see that, you say, okay, that's the end of the email. well, the email is created and sent. But in practice, not everybody follow RFCs. And some of the legacy operating system email implementations actually have a varied way to handle line breaks. So in order to make sure users don't lose their emails, right? False positives are always costly. So real-world email services or implementations or softwares are pretty flexible in terms of what count as end-of-data indicator. So they end up accept other format as well. So this /n./n is one of the format that would cause certain servers to misinterpret this as the end of data and to say, okay, the first email ended, next thing come must be another email, right? So that's why. Now, from the sender's perspective, nothing looks wrong from the email. This is a legitimate account sending a legitimate, sender don't check the legitimacy of the content usually. So this is one email sending out of Microsoft. But on the receiver side, there's actually two emails coming in, one from the contractor, the other one from CEO. Most importantly, this will not raise any alerts. If you think about SPF and DMARC protocol I just mentioned, this is from Microsoft.com IP address. It's on the allowed SPF record. So that's why no alerts will show up on this email. Well, you say, okay, this is hard, right? So getting a contractor email, getting a Microsoft account is difficult in the first place. What about the external attackers? Here's the answer, right? It turns out that you can register a free Outlook email as well. This is open to everybody, and then you replicate the same attack, it still works. Well, the reason for this is Microsoft.com and Outlook.com have a shared SPF infrastructure, meaning that when they publish their SPF record, they will have this include mechanism or link mechanism to say, okay, Outlook.com can send an email on behalf of Microsoft.com as well. Well, we wanted to show this is realistic as a proof of concept. This is a test we did last year. So we actually didn't spoof CEO. Don't want to do that. So we spoofed the admin at Microsoft.com. That address is really hard to get either, right? So we want to show that this is a spoofed through a Outlook account that we get for free. And you can see in the second half, it's a pass. SPF didn't raise any alerts. Everything is legit. Now, you will say, okay, what else? Well, it turns out this shared SPF infrastructure has not just Microsoft. There's OpenAI. You can spoof the CEO of OpenAI, GitHub, many companies. Because these days, nobody runs their own email services. Not nobody, right? But most people, like most small organizations or companies, they host their email services with popular email providers. Therefore, SPF deployment is also centralized and deeply connected. It's a big trusted circle. So open sort of free Outlook accounts goes a long way to look at how many companies or organizations you can attack. That's kind of just the preview of what I'm going to talk about, right? But what this research is about, right? So we try to look at SMTP smuggling risk throughout this different email infrastructure to see who made the mistake, where it's coming from, and whether they're fixing it, right? Because the initial vulnerability was discovered by a research lab that did proper vulnerability disclosure and notify relevant parties. That was in late 2023. It has been a year and two, and we want to see what's going on in the field. Did people implement defenses? Are they effective? Are there overlooked corners? So from methodology-wise, for the first time, we figured out how to do large-scale testing ethically against the private email services. This is a very difficult problem historically because you cannot really, testing people without their cooperation. But how do you do that without being, considered as intrusive and annoying, right? So this is something we try to figure it out in this project as well. So as you kind of remembered, right? So SMTP smuggling required two things, right? So you require the sender server to ignore this malicious end of data indicators and send the email over. It also requires the receiver server to be vulnerable, like misinterpret this end of data indicator and split the data email into two, right? So therefore, in the sort of testing or methodology design, we'll look at testing the behavior of both of the sending server and the receiving server as well. So before we look at how we perform the testing, we also wanted to, kind of identify potentially misinterpretable indicators, this so-called attack payload. Obviously, you don't want to do this against the live services. So what we did is we set up open source email softwares, a bunch of them locally, and do a fuzzing test, right? So essentially consider all the ASCII characters and Unicode characters and figure out what are likely to trigger those behaviors. We end up finding 13 of those payloads that actually show up on at least one of the open source software as a kind of the initial set. Of course, this is not a very complete because this is going to be heavily biased against the open source software we can get our hands on. So not all the email services use open source software, but this is a kind of good indicator as to what likely to work. Now, in terms of testing public and private email services, we actually needed different methodologies. For public email services, meaning that they're open to the public to register accounts, like Gmail, like Outlook. So we can just create our own accounts and only sending or receiving emails from those accounts so that we can leave any other users alone from the service, because we don't care about sort of client-side behavior, but more of the server-side behavior. So what we do is register accounts and send receiving emails from these accounts and look at the results. Pretty straightforward. For private email services, things get a little bit difficult because first you cannot register an account because private companies wouldn't open to researchers to register accounts. Without accounts, it's difficult to verify outputs. So for example, how do you tell the email was actually split into two on the receiving side? It is also unethical to spam a lot of testing emails against any accounts, to be honest, right? So we wanted to do this very, very carefully. So for private email testing, we started with a user study. This is a kind of methodology that allow you to get explicit consent from users who are willingly to participate and help you with the test. So that won't consider as a spam or annoying anymore, right? So we say, hey, if you want to help, look at your inbox and tell us what happens. So we get volunteers from 48 universities, 5 countries, supervised the sample, by the way. And we end up finding 23 universities whose email system has this vulnerability. So we notify the responding teams. The point here is not just getting a very small sample of biased results, but more so to test a bunch of methodologies that we wanted to do some passive testing, right? So one of the question is, how do you know that the email actually successfully split into two, right? So we found that there's a DKIM side channel you can use. The idea here is to embed DKIM is one of the authentication protocols as well. So the point is to get a signature of the message so that the sender usually have a DKIM verification process that will contact your server and get the key and verify the message authenticity. So if you embed the DKIM signature, which is the yellow part, in the second smuggled email, so if the second email was successfully splitted into two and the second email was formulated, that DKIM signature will become a valid signature that they will contact your server to do verification. So you actually can know that email was successfully created on the receiver side without actually any user corporation. Right? So this is a side channel that allows you to verify the outcome of the results passively. But there are more things we needed to take care of, right? So just a little bit, preview. We use a non-intrusive testing methodology to scan top 10K domains ranked by a Tranco ranking list and find their email domain, and then test against their service. So we found 1,577 private email services are vulnerable to smuggling attack. As I said, right, so just be able to verify the output passively is not enough, right? We need to do more. One thing is that we don't want to send any testing messages to normal user accounts. So we decided to send one email to the email administrator accounts or account names that is reserved, defined by RFC, for security reporting, like secure security@some emaildomain.com or info@someemail.com. Those usernames are usually not open for user to register. They're reserved for security reporting purposes. And the second thing is that even sending email to those accounts, right? So if you are not vulnerable, these administrators don't like to receive random testing emails as well, right? So our idea is to combine a testing email payload with the vulnerability disclosure reports in a single message. If your service is vulnerable, the only thing you receive is the vulnerability report. So just happen to tell you your service is vulnerable. But if your email is not vulnerable, so we designed the payload in a way that will automatically terminate and there's no email being sent. So that users who are not vulnerable, services that is not vulnerable will never be bothered. They didn't see anything in their inbox, right? That's why we do this non-intrusive testing that allow us to, convince everybody this is sort of ethical. So how we do this? So this is an example of the payload. The trick here is that this payload never have the official end of data indicator. You didn't see the /r/n./r./n, right? What this means is that if the target is not vulnerable, from their perspective, so first they will not misinterpret this /n./n, this is the attack payload, because they're not vulnerable. They will not misinterpret it. Everything is just legitimate content. But because this email never had the end of data indicator, they will say, okay, this email is never finished. I need to wait for more content to come. So they will just pause and wait. And on our side, we're going to wait for 10 seconds or any kind of threshold, and then we terminate the session. So in this way, no email will be sent, and we know they're not vulnerable. If they are vulnerable, so they will misinterpret this /n./n, the same email content, and the first part of the email will be splitted and delivered to the inbox. And as you can see, the first half of the email is actually a vulnerability report where we write all the information about why you're vulnerable, what's the payload, who we are, a lot of the information that allow us to, allow them to contact us for more information, and also they learn a little bit about what's happening. But the second half of the email is the same trick. As you can see, there's no real end of data indicator. They wait, and terminate. So the second email never gets sent over. So the whole outcome of this is that they receive a single email with the vulnerability report. So this is how we do the large-scale testing. We could do a lot more, but we're also a little bit nervous about this methodology. We just did 10,000 scans, right? So we hope to publish the work then other organizations to convince their RRB to do more scanning. So this is kind of the overview of the results. So as you can see, we test the public email services, private email services, open source email software, and email gateways. Many of them still vulnerable after a year of the vulnerability disclosure. So we further notified them about this issue. Well, part of the reason why they're vulnerable is we identify way more attacking payload compared to the initial disclosure through the fuzzing. So that additional payload is something they don't react to. As you can imagine, the first vulnerability disclosure, they will only fix in the very initial vulnerability reports, probably several end of data indicators that email services are vulnerable, but they didn't do further testing, so the fuzzing really helped to discover more. So here's the results, a little bit deeper dive to the public email services. Here's the 22 email services we can get our hands on with the free accounts, and this is the sending side. So I want to draw your attention to the red check marks. These are vulnerable services that let emails sent through without doing anything. The orange check marks is even worse because on the sending side, they already split the email into two. It's supposed to happen on the receiving side, but the sending side actually did a bad job there. You can also see that many services already start to implement certain defenses. The little gray color symbols represent either dot stuffing, meaning that they found a suspicious strains, they add additional dots to remove the maliciousness. They do string filter, they found some suspicious strains and they removed that string. But very ad hoc fix, very reactive to the initial vulnerability disclosure, but often incomplete. Most of the services, for example, fail to recognize this 0-0 thing that come out of the fuzzing test. On the receiver side, 8 out of the 22 were vulnerable. Some of the common defenses is to reject or truncate the smuggled emails. But if you combine the vulnerable sending side and vulnerable receiving side, there's 36 combinations that are exploitable. But this isn't just the public services we tested, but as you remembered, the amplification effect of the shared SPF infrastructure was the real deal. Because, let's talk about Microsoft and Google, right? These big players in the email serving domain. They themselves are hosting or link SPF record for a large number of domains. So this table is the one that we're able to measure. So meaning that with the free Outlook accounts, you can send emails on behalf of a lot of those domains that happen to use Microsoft or Gmail services. So just kind of rank their popularity here. You recognize a lot of native Microsoft services, but there are a lot of companies like Instagrams or GitHubs. They're not Microsoft related, just you happen to be a customer. Similar for Google, you have YouTube and many Google services, but Twitter, Netflix, and many other companies are using Gmail as well. Because SPF record concentration is the real issue, where you host your email with Microsoft and you use Microsoft IP address to send an email on your behalf. Your record has to be linked so that your email will be delivered. That itself amplifies the smuggling risk of this kind. So here's another example of, you can spoof YouTube administrator with the free Gmail accounts. You can do a lot of those combinations. So we further test, email software and gateways, and there are many of them vulnerable. We test a lot of historical versions of the software, and they're gradually fixing this issue, but still a lot of there. So just want to quickly say we notified all the parties. Not many, the non-intrusive tests already covered quite a lot of them. For the one like public email services, universities, so we notified them individually. So 6 of them, of the public email providers responded, acknowledged our report. 7 universities responded to the report. But many of them didn't reply. It's just hard to know what's their response. Hopefully they secretly fixed it. We ran the study once. We have not retested what's going on. So we might run another test this year. In terms of mitigations and recommendations, right, the fundamental root cause is that SMTP operates on plain text and cannot distinguish data with commands. Very classic issue. And this is also inconsistent logic between sending and receiving servers to handle those end-of-data indicators because to accommodate legacy systems, right? On the receiving side, the best fixes is just go for RFC and only recognize the official end-of-data indicator. Of course, that will hurt a lot of legacy systems that don't follow this rule. As an internet protocol, you kind of have to have everybody to act correctly in order to work. But of course, you can disable this pipelining mechanism, but this hurting email sending throughput, which is the issue. And on the sending side, there's actually a very easy fix, which is to do data encoding. This is a part of the RFC compliant policy, meaning that you can encode the data so that it's much harder for an attacker to insert the content in plain text and be able to interpret his command anymore. Very easy fix, but again, you needed to convince everybody to do that. Data stuffing and suspicious string filtering, as we can already show, they helps in the short term to do short fixes, but could be really incomplete. It depends on whether another fuzzing test to find another string that will be misinterpreted. So we do have an online service that allow email administrators to self-testing additional payload. So in conclusion, we did a kind of a comprehensive measurement study on this. It's a lot of vulnerable stuff we found, but I think the most important insight is that we could find a way to ethically test a lot of private email services, and hopefully this is a methodology that you don't have to bother non-vulnerable people can generalize to other scenarios. And the other thing is that this centralization of deploying SPF protocol is a concern because essentially rely on IP-based authentication is a big problem because IP addresses is really hard to manage. So you can get a trusted IP in that trusted circle very easily. If you have one weak point to get to the big trusted circle, you are trusted, and the game is over, right? So hopefully we all learned something today, and I'm happy to take any questions. Thank you. Yes.
So for the private email provider test, you reported many more vulnerable private system than those who actually responded to your mail. So does it mean you are using the side channel to detect which of those passive emails go through, and isn't it pushing a bit the boundary of a passive non-intrusive attack? Do you use the side channel to confirm the attack?
Yeah, so if I understand correctly, we confirm these kind of side channel works through the user study, meaning that on the user study, the user actually confirmed they received it, and this is the second email we have, and we corresponding to our side channel to say, okay, all the results checked out, then we know that methodology kind of works.
But in the non-intrusive test against private
provider,
do you also use a side channel or not?
We checked a little bit, but that one actually do not necessarily need the side channel. Because if you have if you have a timeout, means that they are not vulnerable. But if you don't have the timeout, they will send over, and some of the email administrator will send you replies. They actually receive the vulnerability report. That means that they're vulnerable.
So in effect, you are using another side channel, which is the timeout,
right?
On default timeout, which
is
so
different ways to do this kind of
which
testing.
is sort of pushing the boundary of what is non-intrusive or not.
Yes.
Okay, thanks.
Yes.
You said in one of your final slides that you notified a lot of universities and large companies. But was there more to the notification than please update your version of postfix?
Yeah, so we emailed, we basically send those vulnerability reports through emails to the administrators, but also include the software developers of the open source, software, and also the gateway, companies. This is a part of the centralization we're talking about, right? So because these days, people don't write their own software for email servicing, for sure. If you're a company, you often use open source software. So there's few popular software could be the source of what this is happening, but also the email gateway. So a lot of people use gateway services as a spam filter. But if the gateway has the vulnerability to misinterpret the thing, that amplified a lot. So this kind of centralization not only happened on the SPF record, linking or inclusion, but also, a few popular players of software suppliers and gateway services that everybody's using, if they have something that affects a lot of people.
So what can Outlook do except upgrade their version of Exim or whatever?
That's a great question in terms of how things are fixed, right? So the perfect fix would be the several key players fix their software, like the software providers or gateway providers. But for individual services, especially, we noticed that during the outreach to the private email services, where we say, remember we have over 1,000 of vulnerable services identified, and we email each of them. By analyzing the hundreds of replies that we got from the email administrators, they often talk about they're struggling, say, all right, we're using Gmail, right? We're gonna tell the Gmail to fix this, but we cannot fix on our own. They have very limited thing they can do on their side. Actually there was even misinterpretation of what we mean. Sometimes they say, oh, we're running our own email services. We just don't know how to fix this. Maybe we should move to Gmail. That's their response. It's like, oh, we can't deal with this kind of security fixes all the time. Maybe we should just offload the service to a big company. Yeah, it's a harder problem. Yes. Oh.
So I think, really interesting problem and, very clever methodology to be able to sort of responsibly do this disclosure. But I think I disagree with the concern that SPF concentration is the problem, or a problem that should be fixed. Because the SPF checking is a hack. It's not real authentication. It's a hack that worked for a while. And the idea that SPF, concentration, that's just natural evolution. It's a good way to do things and makes the hack no longer work. But that's not the problem of the evolution. It's the problem of the hack is bad authentication. We should do real authentication.
Yeah, so I think this is kind of goes back to people's perception, right? So some of the email providers may think, may disagree that SPF is a hack rather than that's the protocol that we sell to our customers that we're well protected. But I agree with you, right? So in general, if you want me to choose between SPF and a DKIM, I'll go for DKIM. DKIM has its own problem, but it's a signature based. It is much easier to separate from the over reliance on the IP address. Because I generally think IP-based authentication is so difficult to do it right? Think about the cloud-based email providers and how many people can get their hands on their cloud IPs. It just easily poison or into the less trusted IPs. So I agree with you on that end.
We're going to have to take other questions at the break.
All right. Thank you so much.
Thank you very much.
Thank you.